Greetings EGR 180 students. This is an optional unit on SOLIDWORKS Simulation Xpress feature. By the time you've completed this unit, you should be able to create a Simulation Xpress study, assign material properties, apply restraints and loads, perform basic stress analysis, and view the results. Just so you know, there are no Simulation Xpress questions on the CSWA. I offer this only as informational, as so far all we've done is model parts and assemblies, but the true power of SOLIDWORKS is in its simulation abilities. Simulation Xpress provides a tool for basic stress analysis, allowing the user to examine the effects of applied forces on the design. Displacements, strains, and stresses in a part are calculated based on material properties, fixtures, and applied loads. Stress results can be compared to material properties to perform failure analysis. The results can also be used to identify critical areas, calculate safety factors at various regions, and simulate deformation. Simulation Xpress provides an easy-to-use method within the SOLIDWORKS environment to perform an initial stress analysis. The results can be used to improve the design. In Simulation Xpress, stresses are calculated using linear static analysis based on the finite element method. In linear static analysis, it is assumed that a linear relationship exists between the applied loads and the response. The stress-strain relationship is linear, no plastic deformation occurs, and no suddenly applied loads are involved, which of course is not true in the real world, hence why this is used primarily for initial stress analysis. The finite element method is a numerical method for finding approximate solutions to partial differential equations. This technique is widely used for the solution of complex problems in engineering mechanics. Analysis using the method is called finite element analysis. Don't worry about the math here. SOLIDWORKS handles all of this for you. Now, I'm just barely scratching the surface here, but I do want to give you an idea of what SOLIDWORKS can do for you via the Simulation Xpress. In the unit demo, I'll model this part for you and show you how to do a simple force simulation. You should be able to replicate this on your own system. If you have problems, let me know. So here's our simple problem. Determine the maximum normal stress that loading produces in this plate. In a classic statics and dynamics engineering course, you'd have to grind through the math and make plots of how you think the part will react to an applied force. This is what you'd use to find out the normal stress on a part. The classic one-dimensional displacement can be used to estimate the displacement of the problem as shown. But again, don't bother, as SOLIDWORKS will do this for you in the blink of an eye. Well, a little bit longer than that. More math fun for future engineers. Yay. This is actually really pokey stuff here. Here's the model of the part. It's 0.25 inches thick, extruded about the midplane. The material is aluminum plate. As you'll see in the unit demo, setting up and running a simulation is pretty simple. Once you activate Simulation Xpress, it's a matter of setting up a fixture, which is an anchor point, a load, which is the force on the object, and setting the material and then running the simulation. A fixture is a face or edge of the part that you'll make immovable. In our simple simulation, we'll select the back edge. The load is where you apply a force. In our simulation, we'll select the opposite side of the anchor, then we'll enter 300 pounds for the pressure exerted. We'll select reverse direction so that when force is applied, it will create a pulling force on the part. Then you simply tell SOLIDWORKS to run the study or simulation. This will take a couple of seconds, but remember, it's going to do some pretty sophisticated math. When we run large simulations, processing can take hours. When the simulation is complete, it'll provide a number of result outputs, typically von Mises stress, displacement, and stress. Even niftier, and in our case, watch the hole in the bar deform. Pretty cool, huh? Just in case you were wondering what von Mises stresses are, they're widely used by designers to check whether their design will withstand a given load condition. Using this information, an engineer can say his or her design will fail if the maximum value of von Mises stress induced in the material is more than the strength of the material. It works well for most cases, especially when the material is ductile in nature. The concept of von Mises stress arises from the distortion energy failure theory. Distortion energy failure theory is a comparison between two kinds of energies: distortion energy in the actual case, distortion energy in a simple tension case at the time of failure. According to this theory, failure occurs when the distortion energy in actual case is more than the distortion energy in a simple tension case at the time of failure. Distortion energy is the energy required for shape deformation of a material. During pure distortion, the shape of the material changes, but the volume does not change. So, as a failure criterion, the engineer can check whether von Mises stress induced in the material exceed yield strength for ductile material of the material. Okay, so probably more than you wanted to know, but students have asked in the past. Again, this is but the tip of the iceberg when it comes to SOLIDWORKS simulation capabilities, but I hope you found it amusing. In this unit, I covered how to create Simulation Xpress study, assign material properties, apply restraints and loads, and perform basic stress analysis, and then review the results. As I mentioned, there is a SOLIDWORKS simulation demo for this unit in case you want to watch or follow along. Don't hesitate to email me any questions or concerns, and as always, thanks for watching. I hope you've had a great course.